All right, let's put that chain rule into action. Example 2, let h of x equal f composed with g of x, and we want to find the derivative of h at negative a half. And notice again, we've got a g of x function graphed and an f of x function graphed. So the first thing that I'm going to do is I'm just going to build myself a little recipe for the derivative of h, which will look like this. H prime of x should be equal to f prime composed with g of x, derivative of the exterior with respect to the interior, multiply times the derivative of the interior. Okay, now everywhere there is an x, I'm going to take that guy out and replace it with negative a half. Negative a half. Write it real small. Okay, or I guess, you could have rewritten it or something. So now I'm just going to get these values straight off of the graph. So the first thing that I need to do is g of, whoa, what are you doing? I need to do this g of negative half, and this is just a function value here. There's no derivative on that one. So on the g of x function at negative a half, it looks like it's a linear function here with a slope of negative 1, so it should be at a half. So that's equal to f prime composed with 1/2 times, and now this is the derivative at that same exact spot. So the derivative at that spot, it's linear. Again, its slope is negative 1, so we're going to multiply that times negative 1. Okay, and now I need one more derivative, and that is the derivative of f at half. So at half, boop. Oh, this is a horizontal line. Slope of that horizontal line there is 0. 0 times negative 1 is equal to negative 0, or, just 0, that's fine. All right, let's look at the same kind of thing except for with a table of values. Sort of like we did for the product rule and the quotient rule, right? Okay, so I don't know, I may not have enough space here. Let me put an extra page. There we go. So we've got, in our table of values, we've got f of x, g of x, together with the derivatives of each of those functions at specifically negative 1 and 1. We want to find the derivative with respect to x of f composed with g of x at 1, and then do the reverse. So let's find part A first. Makes sense? Okay, so I'll build that recipe first. F prime composed with g of x, and multiply that times the derivative of the interior function, g prime of x. Everywhere there's an x, I'll take it out and I'll replace it with a number 1. Okay, as we did before, this part here is just the y value at 1. So at 1, that's equal to a negative 1. F prime of negative 1 times. And now my g function, its derivative at 1 is 2. Okay, and now one more little piece here. We want to find the derivative of the f function at negative 1, which is 5. Multiply those two rates together and we get 10. Okay, one more of these little guys. We want to go in the reverse order. So for part B, we've got g prime composed with f of x times f prime of x. As we did before, we'll take out our x's and replace them with a negative 1 this time. Okay, so from the table, I'm going to get, first of all, f of negative 1, just the y value. F of negative 1 is positive 1, g prime of positive 1, times the derivative of f at negative 1. So the derivative of f at negative 1 is 5. And then what is the derivative of the g function at 1? G is 2. Whoops. 2 times 5 is equal to 10. We got another 10. Is that always going to happen? Well, I'm not going to say that. We only did one example. You can't make a conjecture based on just one example, can you? I don't think math works that way. Okay, so of course, notice that we just did our chain rule with a set of graphs, a table of values with our functions. So for the rest of this, we're going to look at, with explicit equations, how to apply the chain rule.